Hello my dear students, welcome back to Bright Learning app. Now we are going to discuss an important concept in this, some basic concepts of chemistry, that is law of chemical combination. What is law of chemical combination? You know, the atoms will take part in chemical reaction. You know, what is chemical reaction? Chemical reaction is nothing but reactant molecules will convert to product. That is conversion of reactant to product. That is called a chemical reaction. Okay, and that chemical reaction will follow some rules or some laws, and that laws are called laws of chemical combination. Okay, in a chemical reaction, the reactants will convert it to product. How the reactants will convert it to product? First of all, the reactants will react together, or they will combine together, and they will convert it to product. Okay, or we can say that the product is getting by the combination of reactants, and that combination follows some important laws, and that laws are called laws of chemical combination. Okay, we have 5 laws are there to learn. Most important 5 laws coming under the category of laws of chemical combination. Have you clear? It's a general idea. Here the first law, you are very familiar with this law, that is law of law of conservation of mass. That is the first law. Okay, and this law of conservation of mass is proposed by our Antoine Laurent Lavoisier, or simply Antoine Lavoisier. Okay, and this is a great scientist and given lot of contribution to chemistry, and he is considered as father of modern chemistry. Father of modern chemistry is none other than Antoine Lavoisier. Okay, and you may remember the name of hydrogen and oxygen is given by Antoine Lavoisier. That elements not discovered by Antoine Lavoisier, but the name given by Antoine Lavoisier. Okay, and he is the first scientist classified the elements into metals and non-metals. That is also Antoine Lavoisier. Okay, and during photosynthesis, plants are taking carbon dioxide, and the plants are given oxygen back. They are taking carbon dioxide from atmosphere, and they are given back oxygen. Okay, and during this photosynthesis, atmosphere get purified. As you know, that means the amount of carbon dioxide is decreasing and amount of oxygen is increasing. By that process, atmosphere get purified, and that idea first extended by Antoine Lavoisier. Likewise, lot of contributions are there by our great scientist Antoine Lavoisier, and he is the scientist proposed law of conservation of mass. Okay, and he studied, he made careful experimental studies for combustion reactions. Okay, after the studies of combustion reactions, he made a conclusion that during a chemical reaction, either it is physical or chemical process, okay, during a chemical reaction or simply a reaction, there is no loss of mass. That means the total mass of reactants will be equal to total mass of product. Okay, and this law he is proposed during the year 1789. He is proposing this law of conservation of mass. According to law of conservation of mass, we can generally say that during a chemical reaction or during a process, total mass of reactants will be equal to total mass of product. Okay, that's a very important idea. In other way, the most common definition, as you know, during a chemical reaction, matter can neither be created nor destroyed. Matter can neither be created nor destroyed. This is also called the law of conservation of mass. Okay, for more clarity, let's take an example, dear students. First of all, I'm taking a methane. I'm taking methane. Okay, otherwise you can take any example you can take. First of all, I'm taking methane, CH4. You know, when the CH4 is reacted with oxygen, and that is called combustion. What is combustion, dear students? Combustion is nothing but burning. That is nothing but reaction with oxygen or reaction with oxygen in air. That is called combustion or burning. So I'm taking oxygen. When this reacting together, that means methane is reacted with oxygen, that is called combustion. What will be the product? A general point we must remember that when a hydrocarbon, methane is a hydrocarbon. Why? This only contains two elements. One is carbon, second one is hydrogen. The compounds which contains only carbon and hydrogen is called hydrocarbon, isn't it? That is called hydrocarbon. When hydrocarbons undergo oxidation, always the product will be carbon dioxide and water. Always the product will be carbon dioxide and water. This will be the product we will get, isn't it? So dear students, let us take first of all we want to balance the reaction. Here we have one carbon, here also we have one carbon, here we have 4 hydrogen, here we have only 2, so let's multiply with 2, so we will get 4 hydrogen at the right side also, and here we have only 2 oxygen, here we have 2 into 2 H2O means 2 oxygen, so 2 plus 2 4 is there, so let's multiply with 2 at the left side. Okay, so now we got a balanced chemical equation of combustion of methane. This is methane, only contain one carbon, so methane, so methane. Yeah, in the last chapter, 12th and 13th chapter, we'll discuss organic chemistry, very interesting area. They will detailedly we will discuss nomenclature and all the chemical reactions of organic compounds. Okay, so here when methane undergoes combustion, we will get carbon dioxide and water. So what will be the mass of methane, dear students? So mass of carbon, if you take the atomic after the discussion of law of chemical combination, we will discuss atomic mass, molecular mass, etc. But to explain this concept, we want to know the atomic mass of carbon. Atomic mass of carbon is nothing but 12 gram. If you are taking mass in gram, we will get 12 gram. So carbon is 12 gram, and what is hydrogen? If you take one hydrogen atom in gram, that is 1 gram, isn't it? So here we have 4 hydrogen, so 4 gram. So totally we will have 12 plus 4, 16 gram. 16 gram methane is here. Okay, and what about oxygen? One oxygen having 16 gram. If you taking the atomic mass in gram, we will get 16. Here we have taking O2. O2 means 2 oxygen, that is 32 gram. Here we are taking 2 molecules of O2. 2 molecules of O2. So 2 into 32, we will get 64. Okay, so here we have 64 gram. Okay, so when we add this 2, we will get how much gram? Here 64 and 70, 80 gram will be the total mass of the reactants, isn't it? If you take the mass of reactants, that is equal to 80 grams. And if you take the mass of product, here we have carbon dioxide. Carbon having atomic mass 12 in gram, 12 gram, and oxygen is 32. Very well, oxygen is 32. 1 oxygen 16, 2 oxygen 32. So when we add this 2, we will get 44 gram, isn't it? So carbon dioxide is 44 gram. And if you take H2O, hydrogen is 1, 2 hydrogen 2, oxygen is 16, 2 plus 16, 18. We are taking 2 molecules of water, so 2 into 18, 2 into 18. What will be the sum? We will get 36 gram, 36 gram. Okay, when we are adding this 2, what is the sum, dear students? 40 plus 30, we will get 70, then 6 plus 4, 10. So the total is we will get 80 grams, isn't it? So you can see here total mass of reactants will be equal to total mass of product. That means during this chemical reaction, mass is neither created nor destroyed. That's the idea we are getting here. Instead of using mass, we can use the term matter also. Mass is an example for matter. The definition of matter. Matter is anything which occupies in space and possesses a definite mass. Okay, so what is law of conservation of mass, dear students? It states that during a chemical reaction, matter can neither be created nor be destroyed, or mass can neither be created nor be destroyed, which means during a chemical reaction, total mass of reactants will be equal to total mass of product. Okay, and this is the explanation or the example for that, or the proof for law of conservation of mass. Okay, in this combustion of methane, at the left side or at the reactant side we have 80 gram, at the product side as well we have 80 gram. Okay, so no mass is created and no mass is destroyed during the combustion of methane. CH4 is methane. Have you cleared this? Very simple idea. So I'm repeating, dear students, a chemical reaction is nothing but combination of reactants to the formation of product. Okay, and that combination is followed by some laws, and that laws are called laws of chemical combination. The first law is law of conservation of mass. It is proposed by Antoine Lavoisier, considered as father of modern chemistry, and he is proposing this law during the year 1789. It states that during a chemical reaction, mass can neither be created nor destroyed. That means during a chemical reaction, mass will not destroy and will not create. Okay, that means total mass of reactants will be equal to total mass of product, and this is an typical example for that. Here we can prove that total mass will be equal to total mass of reactants will be equal to total mass of product. Have you cleared this idea? Very simple ideas, dear students. So 3 points are very important. First point, which is the law of conservation of mass. And the second point, and also you must know the definition of that law. And the second point, who proposed that law? You must be able to tell. Law of conservation of mass is proposed by Antoine Lavoisier. Okay, definition is important, and the scientist who proposed that also very important. And the third one, you must give an illustration. That means you must be able to explain the law by using an example. Okay, here we have an example. This to prove that total mass of reactants is equal to total mass of product. These 3 points are very important for all law of chemical combinations. Okay, first point, the definition. Second one, the name of scientist, and the third one, the illustration by using an example. Have it clear? Yes. So the first law is a simple law. Matter can neither be created nor destroyed. Antoine Lavoisier, and this is an example. Okay, so let us move to the next law, dear students. That is law of definite proportion. Law of definite proportion. Okay, and this law of definite proportion is proposed by a great scientist, Joseph Proust. This is proposed by Joseph Proust, dear students, very important. It is proposed by Joseph Proust. Okay, very important. And so the name of scientist is clear. That is Joseph Proust, because in the some match the following question, they will give the name of scientist. So we must be able to fill that or connect that. So we must know the name of scientist. So law of definite proportion is proposed by Joseph Proust. Okay, and what is the definition? Or what that law tells? Very simple. It states that a given element, always contains exactly same proportion of elements by weight. This is called law of definite proportion. I am repeating, a given element or a given compound always contains exactly same proportion of elements by weight. Okay, let us take, it states that you can take a given compound, any compound you can take. Okay, a given compound always contains exactly the same proportion of elements by weight. Okay, irrespective of the source. You can suppose we are taking carbon dioxide. We are taking carbon dioxide. As you know, during the respiration, carbon dioxide is coming out, isn't it? During respiration, carbon dioxide is coming out. So we can collect carbon dioxide that we are getting from respiration process. And the same carbon dioxide we can collect by the gas expelled from the automobiles. You know, if you are taking a vehicle, when it is moved by using the fuel, it will expel some gases, some air, and which contains what? Carbon dioxide and carbon monoxide. And we can collect that carbon dioxide from the automobiles, carbon dioxide from automobiles, isn't it? And also we can collect carbon dioxide from some industries, you know, in some industrial preparation process, carbon dioxide gas will come out. For example, in cement industry, in the calcium carbonate industry, there will carbon dioxide gas will come out. So I'm collecting carbon dioxide gas from 3 different sources. You can see here, this I collected from the respiration process. I got this carbon dioxide as a result of respiration, and the second one I collected from the expelled gas from automobiles, and the third one I collected from the byproduct in the industries. Okay, so let me ask a simple question. And how many carbon atoms are present in the first carbon dioxide? Only 1 carbon dioxide. And how many oxygen atoms are present? Here we have 2 oxygen atoms are present, isn't it? And what about the second one? The same proportion. And what about the third one? Same proportion. So dear students, irrespective of the source of the compound, we can say that if you're taking a given compound, from any source you can take. Okay, suppose you are taking water molecule, suppose you are taking water molecule, H2O molecule, you can collect some water from your well. Okay, and also you can industrially prepare some amount of water in your laboratory by using oxygen and hydrogen. You are synthetically preparing that. Okay, and some amount of water you are collecting from your well, and some amount of you are collecting from rain. No doubt. And also suppose we are importing some amount of water from America, any part of the universe, you can bring some amount of water. No doubt that all the water molecules or the compound water always contains hydrogen and oxygen in 2:1 proportion. That means the oxygen present in water and hydrogen present in water, and its proportion will be same irrespective of the source. You can take any from any source you can collect water molecule, or any other source you can collect, and all the given compounds always contains exactly same proportion of elements by weight. That is called the law of definite proportion. Okay, and our Joseph Prost worked with 2 samples of cupric carbonate. He's worked with cupric carbonate. Okay, and it is given here. First sample, he have worked with 2 samples of cupric carbonate. The first sample is natural sample, and the second sample is he's manufactured, and it is a synthetic sample. Okay, one it is a natural sample, second one is synthetic sample. That means the source is different. From different source he are taking cupric carbonate. One is natural, from natural source, and the second one is synthetic one. Okay, and he is researching the composition of elements present in that cupric carbonate, and he is getting exactly same proportion of copper and the same proportion of carbon and same proportion of oxygen. Okay, either it is a synthetic and natural, no change. The proportion of elements is same, exactly same, without any change in that 2 samples. Okay, by using this study, he is confirming that given compound always contains exactly same proportion of elements by weight. No doubt. Is it clear, dear students? No doubt. That is called law of definite proportion, and this law also called the law of constant proportion, dear students. What? Law of constant proportion. Law of constant proportion. Law of constant proportion. Okay, instead of definite we can use the term constant also, because the elements and the composition will be constant always irrespective of the source. Have you clear this idea? So the first point, which is the law of definite proportion, also called the law of constant proportion. Who's proposed this law? Joseph Prost. Joseph Prost proposed law of definite proportion. Okay, and the second point, the definition. How can we define law of definite proportion? A given compound always contains exactly same proportion of elements by weight. That is called the law of definite proportion. Okay, and we must be able to illustrate by using any example. You can take cupric carbonate that is taken by Joseph Prost, and the composition of copper carbon oxygen will be like this. And if you take carbon dioxide, if you take water, any compound you can take from different source you can take, but the composition of elements will be exactly same by weight. Have it clear? Yes, and this is called, dear students, law of definite proportion. Very simple idea. And law of chemical combination is a very important area. We can expect more number of questions from this part. Okay, very important. So let us move to the next question, dear students. So already with two laws of chemical combination we covered. The first one, law of conservation of mass, proposed by Antoine Lavoisier, and the second one is law of definite proportion, proposed by Joseph Prost. Have you clear? Yes. So let us move to the next important law, that is law of multiple proportion. Law of multiple proportion. And this law of multiple proportion is proposed by John Dalton. John Dalton during the year 1803. 1803, John Dalton proposed law of multiple proportion. Law of multiple proportion. Okay, who proposed this? John Dalton during the year 1803. And how can we define this law? Very important. Scientist name, the definition, and its illustration with an example. Very important. So we can define like this: if two elements can combine to form more than one compound, if two elements are combined together and forming more than one compounds, the mass of one element that combines with a fixed mass of other element are in a ratio of small whole numbers. Okay, by simple reading we may not understand this well. Okay, so let us take an example. I'm taking two elements. Okay, the first one is hydrogen and the second one is oxygen. First of all, I'm taking what? Hydrogen. First of all, I'm taking hydrogen. Okay. So suppose, if we are taking H2 molecule, hydrogen means H2 molecule. Suppose we are taking H2 molecules, what's the mass of, molecular mass of H2? That is 2. If you are taking in gram, that will be 2 gram. No doubt, that will be in 2 gram. Okay. And the second element I am taking, oxygen. Second element I am taking, that is oxygen. Oxygen. Okay, we can take either an oxygen atom or a molecule of oxygen. Okay, here I am taking oxygen atom. I am taking oxygen atom. What's the atomic mass of oxygen? You must know that is 16 gram. So we have to give that here, 16 gram oxygen we are taken. Okay, when it react together, that means when hydrogen and oxygen react together, what will be the product? Here we have only taking one oxygen atom, is it not molecule? So the normal product will be water. Normal product will be water. Okay, and what's the molecular formula of water? That H2O. And what's the molecular mass? As 16 plus 2, that will be 18 gram. That will be 18 gram. Have you cleared this? Very simple idea, isn't it? Yes. So here these two elements are combined together. We are getting only one product. But this law tells the formation of more than one product, isn't it? When two elements combine to form more than one compound, isn't it? So we want to get more than one compound. So we are taking the same reactant. What is the reactant? First one is hydrogen. And the second one is oxygen. We are taking. Okay, here we are taking the same hydrogen, that means H2 molecule. So the mass is 2 gram. And we are taking O2 molecule. O2 molecule, when we are taking, we will get 32 gram. Okay, so H2 and O2 is combining. So what will be the product, dear students? No doubt, that will be hydrogen peroxide. hydrogen peroxide. That will be hydrogen peroxide having the formula H2O2. H2O2. You know, water is nothing but H2O. Okay, here, because here we are only taking one oxygen atom, but here we are taking O2 molecule. Both are same elements, but one is atom, second one is molecule. Okay, so here we are getting H2O2, here we have only H2O. Okay, so dear students, what's the mass of this? What will be the mass of this? Here we have O2 32, here we have 2, so 34 will be the mass. Okay, 34 will be the 34 gram will be the mass. Okay, so now we can explain law of multiple proportion. That means when two elements are combining, okay, here hydrogen and oxygen is combining, and we are getting more than one compound. Yes, we are getting more than one compound. When hydrogen and oxygen are combined together, we may get water as well as hydrogen peroxide. Okay, so we are getting more than one compound. So the mass of one element, which is the element that combines with the fixed mass of the other element, the element which combines with the fixed mass of the other element. So if we have two reactant molecules or the elements, one is hydrogen and oxygen, which have the fixed mass. If you take oxygen, in the first case we have 16 gram, in the second case we have 32 gram. That means that is a variable mass, that is not a fixed mass. But in the case of hydrogen, you can note that here we have 2 gram, here also we have 2 gram, isn't it? So we can say that, so we can clearly say that hydrogen have fixed mass in this reaction. Okay, so the mass of element which combine with the fixed mass of other element. So which will be the element? Oxygen will be the element. Oxygen is the element which combines with what? Fixed mass of the other element. Fixed mass having for hydrogen atom. So the element which combines with the fixed mass of the element, that will be oxygen. Okay, and that element will have the ratio of simple whole number ratio will be there. That means nothing but if you take this oxygen, we have 16 gram, and then in the second molecule oxygen is 32 gram. Okay, and this is the ratio. As you know, if you divide with the 16, we will get 1, here we will get 2. So it will have a simple whole number ratio, that is 1:2. Okay, so dear students, I am repeating, this is the most important and most repeated question. It is little bit difficult to understand, so I am repeating. So when two elements are combined, we are taking hydrogen and oxygen. We are taking hydrogen and oxygen. Okay, and there is forming more than one compound. We are getting water and H2O. Okay, so the element which combines with if you check the reactant molecule, one element will have the fixed mass and the next element will have the variable mass. Okay, we have to take the element having variable mass, that is combined with the element having the fixed mass. Okay, so the ratio of the element having variable mass will have simple whole number ratio. Like we have to express that. Okay, so here oxygen having variable mass, that is combined with the fixed mass of hydrogen. So the ratio of oxygen will be in simple whole number ratio, 16:32. 16:32, that is nothing but 1:2. Okay, so dear students, simply we can explain one more time that when hydrogen and oxygen combines together, that means when two elements are combined together, they are forming more than one compound. Here we are getting H2O, here we are getting H2O2. Okay, here by just analyzing the molecular formula of this compound, you can see that here we have H2, here also we have H2, here we have H2, here also we have H2. That means it have fixed mass. How much mass it have? Here we have 2 gram H2, here also 2 gram H2. But the oxygen is not constant, that is not fixed, this is variable. So if you take the ratio of this oxygen atoms, that means it doesn't have the fixed mass, we will get this oxygen have only one oxygen is there, so there will be 16 gram, and if you take this, there is 32 gram. Okay, so if you take the simple whole number ratio, we will get 1:2. Okay, so this is a simple idea. By this you will understand that means when two elements are combined together, there is forming more than one compound, and the element which is combined, the ratio of element which is combined with the fixed mass of the other element will have simple whole number ratio. So very clear. Okay, so you should practice this. 3 important points you must learn. First one is the name of scientist, and you must be, second one is the definition, and third one is the illustration by using the example. Okay, and this is a typical example for that. And let us take another example for more clarity. We can take another example when carbon and oxygen is reacting together. Which are the elements, dear students? One is carbon. When carbon and oxygen is reacting together, there may form 2 type of compounds. First one is carbon monoxide, and the second one is carbon dioxide. Dear students, when carbon and oxygen reacts together, there will form carbon monoxide and carbon dioxide. Okay, here you can see one element having fixed mass. Which is the element having fixed mass here? No doubt, that is carbon, isn't it? So here carbon, only one carbon is here. Here also we have one carbon. So carbon having atomic mass 12 in gram, 12 gram. Here also 12 gram. And you can see number of oxygen is different, so it have different mass. Okay, so if you take that element which is combined with the fixed mass of the other element, will have simple whole number ratio, right? Like the previous example. Here also we have 1 oxygen, so that is 16 gram. Here we have 2 oxygen, that is 32 gram. Okay, so if you take the ratio, simple whole number ratio, we will get 1:2. Have you clear this? So like this we can expect questions from the side. Okay, so dear students, what is law of multiple proportion? Before that, who proposed this law? That is proposed by John Dalton in the year 1803. And what's the definition for that? You must be first you write this in your notebook and try to by heart that and try to understand that more. Then you must be able to write in your examination paper. So if 2 elements can combine to form more than one compound. Okay, that's the first point. When 2 elements combine to form more than one compounds, we are getting 2 compounds. Okay, the mass of one element, which is the element which combines with the fixed mass of other element, are in the ratio of small whole number ratios or simple whole number ratios. Okay, and this is called law of multiple proportion. Dear students, most important question, most important and repeated question from this law of chemical combination part. Okay, and the illustration is very important. By using any example, you must be able to explain that. Okay, sometimes they will give that when hydrogen and oxygen combines together and there is forming 2 compounds, one is carbon dioxide and carbon monoxide. And this is based on which law of chemical combination, they will ask, and who's proposed that, and explain that. Likewise, we can expect questions. Okay, and if you sometimes it is based on hydrogen and oxygen, sometimes carbon and oxygen. Okay, any other questions? If you are getting when 2 elements are combined together, if you are getting more than one compound, and that in that compounds, the element which is combined with the fixed mass of the element will have in the simple whole number ratios. Okay, you must remember the definition as well as the name of scientist and the illustration by using an example also. Have you clear this? Okay, so let us move to the next question, dear students. That is Gay-Lussac's law of gaseous volume. Gay-Lussac's law of gaseous volume. Okay, from the name itself, you will get that this law is suggested by Gay-Lussac. This law is suggested by Gay-Lussac. Okay, or the complete name is Joseph Louis Gay-Lussac. Joseph Louis Gay-Lussac is proposed this law. Okay, during the year 1808. Gay-Lussac proposed this law of gaseous volume. Okay, and which states very simple: when gases combines or produced, when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume. Provided all gases are at the same temperature and pressure. That means, dear students, at same temperature and pressure, if gases are combined or it is formed in a chemical reaction, they do so in a simple whole number ratios of their volume. simple whole number ratio of the volume. This is called the law of gaseous volume proposed by Gay-Lussac. Okay, let us take an example. Because this law is related to the volume. This is related to volume. Okay, so let us take, suppose I am taking 100 milliliter hydrogen. I'm taking 100 milliliter hydrogen. I'm taking what? I'm taking hydrogen. That is 100 milliliter. When it is reacted with oxygen, that I am only taking, I'm not taking 100 milliliter. Here I am taking 50 milliliter. Okay, 50 milliliter. When this hydrogen and oxygen is combined together, we will get water. As you know, we will get water, and that water having 100 milliliter volume. 100 milliliter volume. So in this example or in this reaction, you can see that when two elements are combined, when two that elements are in gaseous state, when gases are combined, here it is given, when gases are combined or produced, here water is not a gas, it's a liquid, as you know. So when gases combines or produced in a chemical reaction, when a gas is combined or produced in a chemical reaction, they do so in a simple whole number ratio. So if you take the gaseous reactants, the combined gaseous reactant, you can easily get the ratio. Here we have 100 milliliter, here we have 50 milliliters. So what's the ratio when we are dividing with the 50? So we'll get it 2:1. 2:1 is the ratio. Okay, this is actually liquid state, so we are not taking that. So when the gases are combined or produced in a chemical reaction, they do so in a simple ratio by volume. Okay, there is a condition. This reaction must be at constant temperature and pressure. The reaction must be at constant temperature and pressure. Okay, so very simple, dear students. Very simple example. So let us take another one. Okay, we can take another one. Suppose we are taking Haber process. What is Haber process, dear students? What is Haber process? I'm taking N2. It's a gas. When it is reacted with a 3H2, that also gas, we will get what? 2 ammonia, NH3, that is also gas. Okay. Here we have coefficients of 1, but here we have 3, here we have 2. Okay, so instead of that, we can take that in volume. So for general understanding, I'm taking, here we have 1 volume. Here we have 3 volume. Only for general understanding. Here I'm taking 2 volume. Okay, suppose it is in STP, you can take that, the volume of a gas in STP, you can take 22.4, okay, or 22.7. So here we can say that suppose this reaction is carried out in standard temperature and pressure, we can give 22.4 liter N2, here 3 into 22.4 liter H2, here 2 into 22.4 liter NH3. You can take like that. For general purpose, we only take 1 volume, 3 volume, 2 volume. Okay, all are in gaseous state. Okay, so here the two gases are combined together and a gas is producing. Okay, and this all are do so in a simple ratio by volume. So we can take, here we have 1:2, here we have 3:2, here we have 2. Okay, if you take only reactants, you can write 1:3. If you all are in gaseous state, so you can take the product also. So this reactions is carried out in the ratio by volume of 1:3:2. Okay, likewise we can represent the reaction. So I am repeating the concept at the constant temperature and pressure. That is very important. Temperature and pressure is changing, this law will not work out. So we can say that at a constant temperature and pressure, if gases are combined or produced during a chemical reaction, that do so in simple ratio by volume. Okay, simple ratio by volume. So you must remember two important points. Here we are considering the combination or the production of gases. Okay, and this we are explained in terms of volume. That is very important. The previous three concepts are based on the atomic mass actually. First one, law of conservation of mass, and the second was law of definite proportion. There also we are taking the in weight, okay, same proportion of elements by weight. That means that also related to mass. And the third law of multiple proportion, that also related to mass, okay. But here Gay-Lussac's law of gaseous volume, it is related to what? Volume. Okay, not mass. Okay, and here we are considering gases, the combination and the production of gases or the formation of gases that is carried out at constant temperature and pressure will do so in ratios of simple ratios by volume. Okay, that's idea suggested by Joseph Louis Gay-Lussac. Have you clear, dear students? Very important. In the first example, the ratio between the reactant is 2:1. Here if you take the reactant as well as product, this is Haber process, 1:3:2. Likewise, we will get the ratio of volume we will get. Have you clear, dear students? Very simple, very simple. But here also three important points. Name of scientist, Gay-Lussac, okay, or Joseph Louis Gay-Lussac. Second one, its definition. Third one, its illustration by using any examples. Have you clear? Yes. And dear students, the more clarity in the law proposed by Gay-Lussac is given by another scientist, that is Avogadro. Okay, and he also suggesting his own law called Avogadros Law. Avogadros Law. This is the most important law. Avogadros Law, most important law. And which states, very simple, you know, equal volumes of all gases. Equal volumes of all gases at the same temperature and pressure. What? Equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Very simple. Equal volume of all gases. Equal volume of all gases contains equal number of molecules. That is a concept. Okay, equal volume of all gases. If volume is equal, the number of molecules also will be equal. But the condition is at same temperature and pressure. In the previous law, that is Gay-Lussac's law of gaseous volume, also the condition is at constant temperature and pressure. Okay, here also the same point. At constant temperature and pressure, equal volume of all gases contains equal number of molecules. Okay, let us take the previous example that we discussed in the Gay-Lussac's law of gaseous volume. That is, we are taking hydrogen. We are taking a hydrogen. We are taking how much the volume of hydrogen? That is 100 milliliter volume of hydrogen is reacted with oxygen. It is reacted with oxygen. That is 50 milliliter we are taking, and we are getting what? H2O, that is in that means water we are getting, that also in 100 milliliter. Okay, so let us take, here we have 100 first of all we can take a 50 milliliter oxygen. Okay, that is we are taking here, that is one volume we are taking oxygen. One volume we are taking oxygen. Why we are taking one volume? If you take the balanced chemical equation, we will get like this. Okay, we will get 2H2, okay, and O2 gives 2H2O. We will get 2H2O. In this reaction, we are considering the product water is in vapor state, that is in gaseous state. Okay, because we are discussing about gaseous. Okay, so we can only consider the gaseous reaction. So here we have to take the water in gaseous state or in vapor state. Both are same. Okay, so here hydrogen is in gaseous state, oxygen is also in gaseous state, water is also in gaseous state. Okay, so here you can note that here we have 2 molecules of H2, and here we have 1 molecule of O2, and here we have 2 molecules of H2, isn't it? That is why we are taking according to law of gaseous volume, we can take here 2 volume of H2 and 1 volume of O2, and here we have 2 volume of H2. Okay, so here we taken one volume of oxygen. Why we are taking one volume of oxygen? Because in this balanced chemical equation we have one volume of O2, isn't it? So if you count the number of molecules, if you take the count number of molecules, you will get 1, 2, 3, 4, 5. 5 oxygen molecules are present in this container. Okay, so one volume of oxygen is already taken, which contains 5 molecules of O2 oxygen. Okay, and the second one we want to get a 2 volume of hydrogen. Okay, and we are taken one volume here and the second volume here. Okay, this is the first volume and the second volume. So totally we have how much volume? 2 volume of H2 here. Okay, and each volume contains 5 molecules. Here you can count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so here also you can count 1, 2, 3, 4, 5. Okay, so 2 volume of hydrogen is combined with 1 volume of what? Oxygen. Okay, and we are getting what? 2 volume. You can note here 2 volume of water. 2 volume of water. Okay, so volume is increased. So number of molecules also will be increased. That is called the law of Avogadros Law. Equal volume of all gases contains equal number of molecules at the constant temperature and pressure. Okay, equal volume of all gases contains equal number of molecules. Okay, so when the number of molecule increases, volume also increases. Volume and number of molecules is directly proportional to each other. So here if you count the number, you will get 1 molecule, second molecule, third, fourth, fifth, seventh, eighth, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 molecules inside this. Why we have 10 molecules? Because this contains 1 volume, this contains 1 volume, this contains 1 volume. Okay, so 1 volume contains only 5 molecules. So here we have 2 volume. When volume increases, number of molecules also will increase. Okay, so equal volume always contains equal number of moles. If you take the first 3 volume, all volumes are equal, 1 volume. So the particles or the molecules present inside that volume also same. Here we have 5 molecules, here 5 molecules, here also 5 molecules, isn't it? So equal volume of all gases contains equal number of molecules. If volume increases, number of molecules also will increase. If you take the first 3 molecules, you can see a volume is same, 1 volume, and the number of molecules also same, that is 5 molecules. Okay, and if you take the product, we have 10 molecules. Why? Because volume is doubled. Here we have 1, 1, 1, but here we have 2 volume, isn't it? So volume is doubled. What will happen for the number of molecules present in that volume? That also will double, isn't it? So that is why here we have 10 molecules. That means we can say that this is the definition. You have to remember this, very important, very important. Equal volume of all gases at the same temperature and pressure should contain equal number of molecules. It is proposed by Amedeo Carlo Avogadro, or simply you have to remember the name Avogadro. Okay, Avogadro. And this and also our Avogadro given lot of other contributions also, that is, you know, he make a clear distinction between atoms and molecules. And do you know what is atoms and molecules, dear students? You know, atoms which contains only one type of particle, or that means only one particle will be there. That means if you take a hydrogen, you know, this is one hydrogen atom, that is a hydrogen atom. Okay, and this is another hydrogen atom. When it is combined together and when it is forming a molecule, we will get like this. Okay, this is H and this is H. Okay, and this is molecule. Okay, this is molecule and this two are independent atoms. When it is combined together and form a stable molecule, we will get H2 molecule. This is called a H2 molecule. Okay, so atoms are combined together and forming molecule. Okay, initially atoms will be independent, and when it's combined together for getting stability, we will get the molecule. Okay, likewise we can take oxygen. Oxygen is an atom. This another atom. When it is combined together, we will get O2 molecule. Okay, likewise, he given a correct distinction between atoms and molecules. That will be very helpful for us. Even now, we are using that for the further studies, etc. That's a basic information that is made by our Avogadro. Okay, and also he given the explanation for homogeneous and heterogeneous mixtures, etc. A lot of contributions are there by our Avogadro. Okay, and this idea, that means this law, it's an important law and say correct law also, that is published by Avogadro in a French journal called De Physique. In De Physique, it's a French journal, he published this. Okay, this is a corrected law. It's a basic and important law, but even though he not get much recognition in that publication, he's not get more noticed. Okay, but it's a good law, it's a perfect law, it's a true law also. Later some years it is noticed and he gets some recognitions, etc. But during the published time, he not get much attention. Okay, so dear students, this all are the 5 laws coming under the category of law of chemical combination. Most important area, law of chemical combination. You must learn this very carefully. I already told you that 3 important points are very important: name of scientist and the definition, and the third one is illustration by using suitable examples. Okay, so dear students, can you remember the first law of conservation of mass proposed by Antoine Lavoisier? It states that during a chemical reaction, matter can neither be created nor destroyed. That means total mass of reactants will be equal to total mass of product. Have it clear? And the second law, and we can illustrate that by taking an example, combustion of methane, we will get carbon dioxide and water. Total mass of the reactants or product will be 80 gram. We already discussed that. You should note that in your notebook and practice. Okay, after that, law of constant proportion proposed by Joseph Prost, it states that a given compound always contains exactly same proportion of elements by weight. Okay, also called a law of constant proportion. Okay, actually his work using 2 samples of cupric carbonate, one is from natural source and second one is synthetic one, he get the same proportion of elements. Okay, and from that observation he's reached to this conclusion that a given compound always contains same proportion of elements by weight. And the third law is law of multiple proportion proposed by John Dalton. As you know, when 2 elements combine to form more than one compounds, the mass of element which is combined with the fixed mass of other element will have the ratio in simple whole number ratios. Okay, very simple idea. And the third one, Gay-Lussac's law of gaseous volume. When gases are combined or produced in a chemical reaction at constant temperature and pressure, it will do so in a ratio of volume, in a simple ratio by volume. Okay, and the third one is Avogadros law. What is Avogadros law, dear students? Very simple idea. Equal volume of all gases under the same condition of temperature and pressure will contains same number of molecules. Okay, so these 5 laws are very important. These 3 points: scientist, definition, and the example. Okay, and different types in tested question also can expect from this area. So listen very carefully and note the important points and try to by heart the points, and also try to practice, and moreover try to understand what the concept. Okay, then only we can solve the questions if they are asking in a tested manner. Okay, if we are just by hearting the concept, we may not answer the questions if the testing questions are coming. Okay, but if you know the correct idea about the law and all other things, it will be very simple. Okay, so try to learn immediately, and if you have any doubt, you can ask in our live session, and we will do more questions in our live session. Okay, so learn very carefully, dear students. All the best.